This is the solution for section 8.2, problem number 5. All right, so directions for problem number 5 says find the area of the region bounded by each set of graphs. All right, so x equals 4y minus y squared, x equals 0 about the y-axis. All right, so first thing we have to do, we have to come up with what is x equals 4y minus y squared. Well, it is a parabola that is facing to the left, right, because the y squared has a negative coefficient. All right, and it's kind of hard to tell exactly what it is. So what I do is I'm going to figure out the zeros, right? So I'm going to actually set 4y minus y squared equal to 0. So what does that mean? I'm figuring out the y-intercepts, right, when x is 0. So if I do that, I get that 0 is equal to, I can factor out a y, so I get 4 minus y. So y equals 0 and y equals 4, which means that there are points at 0, 0, and 0, 4. So it's a parabola facing to the left at going through y equals 0, y equals 4. All right, x equals 0, that's the vertical line that is the y-axis, and we're revolving around the y-axis. All right, so if I'm revolving around the y-axis, that means I want to use a dy cut, right, because the dy is perpendicular to the axis of rotation. All right, so now if I'm using a dy, that means I want my equations in x equals form, which they are, which is nice. All right, so I'm going to start off with pi times the integral of radius squared with respect to y. Now, okay, so now we're taking the radius and squaring it, so now we're taking the upper boundary of the dy. So that's the right-hand boundary, which is the curve, so that's 4y minus y squared, and then we're subtracting the lower boundary. What's the lower boundary? Well, it's 0. All right, so 4y minus y squared minus 0, quantity squared. All right, and we're integrating from what to what? Well, we're integrating from the lowest y value, which is 0. Remember, this is 0, 0, to the highest y value, which is, well, 4, because this is 0, 4. So 0 to 4. All right, so I have pi times. All right, now, if I have 4y minus y squared minus 0, the minus 0 doesn't do anything, so then how am I going to evaluate? Well, I'm actually going to multiply that thing out. So I get 16 y squared minus 8y cubed plus y to the 4th, and then all of that with respect to y. All right, now I understand here the numbers get a little annoying, all right, but this is essentially still a non-calculator question. All right, so pi times, all right, now we're going to integrate. So 16y squared. So this becomes 16y cubed over 3 minus 8y to the 4th over 4, so that becomes 2y to the 4th plus y to the 5th over 5, right? And then we're going to evaluate this from 0 to 4, and so I get pi times, all right, 16 times 4 cubed over 3 minus 2 times 4 to the 4th plus 4 to the 5th over 5, right? And then minus, the pi has to go to this stuff too, but remember this is just 0. So 16 times 0 cubed over 3 minus 2 times 0 to the 4th plus 0 to the 5th over 5, right? So obviously the second part is 0, and so then we are just kind of dealing with this. Now remember, I said the numbers may get annoying, right? But if the numbers turned out a little bit easier, this is certainly a calculator question. AP probably wouldn't give you this because the numbers are just too annoying, maybe, right? So I've got 16 times 4 cubed, right? Of course, 4 cubed is 64 times 16. I know that that's annoying, right? That is 1,024. All right, don't fret over that, that number. All right, and then I have 2 times 4 to the 4th, right? So 4 to the 4th is 64 times 4, which is 256 times 2, which is 512. And then I have plus 4 to the 5th, which is also 1,024 fifths, right? So now, yes, this is certainly very annoying. So if I said, okay, 1,024 times 5, that would give me 5,120 fifteenths minus 512 times 15. I know that this is annoying, 7,680 fifteenths plus, and then I've got 1,024 times 3, of course, is 3,072 fifteenths. All of that multiplied by pi, right? And so then we're taking 3,072 minus the 7680, and then plus the 5120. Sorry, 3,072 minus 7680, and then plus 5120. And so I get 512 pi over 15, right? Now, I get it, dealing with those fractions is annoying, but can you get to this point without a calculator? If that is true, then this is certainly a non-calculator question. All right?